Hello, ladies and gentlemen. This is Mr. McCabe, and this is your lesson on spread and measuring the spread and center using standard deviation and mean. Okay, two things you need to know. Measuring the center, we're going to use mean. This is the average of the observations or of your data. The other thing we're going to talk about is measuring spread. That's going to be called the standard deviation. All right. In order to measure mean, we're going to call this x bar. Standard deviation, we're going to call that S. So S denotes standard deviation, X bar denotes mean. All right, everyone should know what mean is. It's basically taking the average. So mean is X bar. And when I say X bar, what I mean is the sum of the observations divided by the number of observations. So for instance, if I give you the numbers 1, 3, 4, 4, 4, 5, 7, 8, 9, in order to find X bar, we're going to add these all up and divide by however many numbers there were. There were 9 numbers. So this adds up to 45. 45 divided by 9 is 5. So my X bar in this case is 5. So X bar, my average is 5. Okay? Now, the next thing we're going to do is we're going to talk about, now, this all deals with measuring the center of data. All right, so now watch this. If we were to split the numbers, these numbers here, up evenly into 9 observations, they would all have 5. That's what X bar means, is if I were to take all 9 observations and divvy up all the numbers evenly, each one of those would tend to be a 5. Okay? Now, what we're going to talk about is median versus the mean. The median is the middle number of a set of data, and it ignores the values at either end. So for instance, 1 might be really small, 9 might be really large, but the median is going to ignore those two and still give you the middle number. All right, the median is what we say is resistant to a large or small numbers from either end of the data. Now the mean takes the numbers at either end into consideration and is or can be greatly affected if they are very large or really small. For instance, like when you take your average. If you're consistently making 80s in your class and you score a 5 on a test, well, that 5 is so low, it's going to affect your average. Or let's say you make 100 on a test. Well, that 100 is so high, it's going to increase your grade. So the mean is really affected by low numbers and high numbers. For example, if you turn to page 61 in your textbook and look at example 2.10, there are 25 values there, and we already covered this in the notes from yesterday. The median for those 25 numbers is 9. We put them in order from least to greatest, and the middle number is 9. However, if you add all those values up and divide by 25, they add up to 687. Well, 687 divided by 25 is 27.48, which is a lot different than 9. So if you notice those values, let's compare the two values, 9 and the 27.48. Since the values to the right of the median are more spread out, the mean is pulled to the right. So go back and look at on page 61 at example 210. Remember, 9 is the median. The numbers to the left are less spread out. Okay? The numbers to the right are more spread out, causing the causing the mean to become greater. Okay? All right, so that deals with how you describe the center. This is how we describe the center. All right? So we have median versus mean. Median versus mean. Now, what we're going to do is we're going to talk about how to measure and talk about the spread of data. Remember, previously, we talked about the 5-number summary, and we used the IQR, which was Q3 minus Q1, and that gave us the spread. Well, now we're going to talk about another way to measure spread, and in this case, if we use the mean to describe the center, we'll also use what we call the standard deviation to describe the spread. So if you use the mean, which is x bar, to describe the center, you have to use the standard deviation to describe the spread. All right, for instance, what is standard deviation and what is it? The standard deviation is the average distance from the mean. Okay, remember your mean is sort of like your middle number as well. It's the center. So what is the average distance from your center? Well, the mathematical way of doing it is the standard deviation is equal to the square root of the average squared deviation. All right, let me explain that to you. All right, first of all, let's take step one. Step one is to find the distance of each observation from the mean and square each of the distances. For example, let's take the numbers we just worked with, 1, 3, 4, 4, 4, 5, 7, 8, and 9. Let's add them all up. So the averages are, they add up to 45. So 45 divided by 9 is 5. So our mean or our average, our x bar is 5. So we want to find out this, we want to find the distance of each observation from the mean. So in other words, I want to know how far is 1 from 5, how far is 3 from 5, 4 from 5, so on all the way up to 9. So this is what I do. We're going to find the value, we're going to subtract the average or x bar. 1 minus 5 has a distance of negative 4. 3 minus 5 has a distance of negative 2. 4 minus 5 has a distance of negative 1. So on and so forth. If you look, these are the distances that my values, these are these numbers here, are from the mean. Remember, this is my x bar, x bar, x bar, okay? Now, these are the average, this is the distance. Step two is you want to square those distances. So, negative 4 squared is 16. Negative 2 squared is 4. Negative 1 squared is 1, so on and so forth. So step one is find the distance. Step two is to square the distances. Step three is to find the average of the squared distances by dividing by n minus 1. And I'll explain that in class. When you take these distances, these squared distances, and you add them up, 16 plus 4 plus 1 plus 1 plus 1 plus 0 plus 4 plus 9 plus 16, that adds up to 52. Well, what we're going to do is we're going to take that 52 and we're going to divide by n minus 1. Now, n are the number of observations. And if you go back up here, there were 9 observations right here. So there were 9 numbers. So 9 minus 1 is 8. 52 divided by 8 is an average of 6.5. So this average, or this is the average of squared distance, and it is called the variance. So when this is the average squared distance, and we call this the variance. Make sure you know that. So the last step is we're going to take the square root of this average. So we're going to take the square root of 6.5. So this is the square root of this average square distance, sorry. This is called the standard deviation. So when we take the square root of 6.5, our standard deviation is 2.55. So square, or our standard deviation is 2.55. All right, now this is what you're going to have to do on your work tomorrow in class. All right, let me summarize what we're doing. When you have skewed, when you have skewed looking data, you are going to use the 5-number summary to describe your data, which is your cuss and BS. All right? Your center, your outliers, the shape, and the spread. Your center is going to be dealt with X bar. I'm sorry. Your center is going to be your median, and your spread, you're going to use the IQR. Okay? When you have normal data, you will typically use X bar, which is your mean, your average, and S, which is your standard deviation to describe the data, usually free of outliers. So when you have outliers, you're going to use your median and your IQR. When you have normal data, you're going to use the X bar, which is your mean, and you're going to use the standard deviation, all right, to describe the spread. And that is today's lesson.